When we look at this comparison between the model distribution, the distribution implied by the log normal process versus the actual distribution in the equity market, we see that there's a lot more probability for the market in reality to have large negative drops in prices. Now, you may think because of this, um, it is more favorable for holding put versus holding calls, because if you have a deeply out of the money put, this will mean that it is now more likely for this out of the money put to be in the money. And also, if you have a deeply in the money call, this will also means that it's more likely for this deeply in the money call to be out of the money. So you may then think, well, maybe in this case, the impact is to make the deeply out of the money put more valuable and make the deeply in the money call to be less valuable. But in reality, this is not the case, and let's see why. For European puts and calls, with the same strike price and same time to maturity, they will have to have the same implied volatility. It is only approximately true for American options, but absolutely true for European options, European puts and calls. Why that is the case? Why can we compare to the Black-Scholes price? Are we not able to make a European put more valuable, like increase its price compared to the Black-Scholes price, yet at the same time makes the European call less pricey by dropping its price compared to the Black-Scholes price. For the ones with the same maturity and same strike. Now, the put call parity condition itself actually prevented this from happening. So recall, if you look at the put call parity, we have, the Black-Scholes merchant price of call is equal to the put price plus the discounted value of the strike. Plus the stock price, and you have the dividend payment, so you have a discounted dividend here, and also minus the present value of the strike. Okay, now in this case, if you increase the well, right now they have the call and the put have the same volatility. It's one single parameter sigma. Now, if you make this more valuable, increase the price here, and you're not going to change anything on the stock price. So the stock price times this little factor here, which is related to the dividend yield, and this present value of K will not change. So these two parts will not change. And therefore, if you increase the price here, you must increase the price of the call. And otherwise, you will violate the put call parity, and it will lead to arbitrage opportunities. One way to think about this more intuitively is that if you have a put and the larger probability of a downward movement on the stock prices will make the put more expensive, because you will have more value for holding the put, right? Because then it will be in the money and get paid. However, for a call, there's actually something valuable as well, because for a call, you will yeah, if the stock price is lower than the strike price, you actually are protected, because although the value of the call will be 0, the value of the call will not be negative. So you're actually protected in that regard as well. So you can see that for a call, uh, it does protect when you are having very large negative movements. Because compared to holding a stock, a large movement of a large downward movement will means that the stock value was reduced substantially. And whereas for if you are holding a call, you actually the worst you can have is the premium of the call is would disappear, but you will never suffer any more losses than the price of the call itself. Whereas you can, if you hold a stock, you can actually suffer a much bigger loss due to the negative movement of the price itself. So that's one way of thinking about it intuitively, uh, about this phenomena here. And obviously you can, look at the Poco parity and, convince yourself that that is actually the case. Whereas you have the same strike price and same maturity, both the European put and the European call will have the same implied volatility, okay, due to this.